So in this video, we're going to look at the area enclosed between a curve, in this case the curve y equals 3e to the power 2x, and the line y equals x plus 2, using the graphing calculator. First we're going to draw the graph. So on the calculator, open up a graphing page. First equation, 3e, use the e button on the calculator, 3e to the power 2x. There's our exponential curve, and we want to draw the line. Press tab. Second equation, x plus 2. So we've got the exponential curve in a straight line. I can see in here there's an area between the line and the curve. I'm going to zoom in a bit on this area. I think I'll use zoom in. So menu, window zoom, zoom in. Center it where the area is. Press enter. Maybe I'll zoom in one more time. That looks better. We're still in the zoom mode. Press escape to get out of zoom mode. So I want to find this area here. To do that, I need to find out where's the x value of the intersection point and the x value of the intersection point here. So I can get the limits for the integral. So first I need to get those intersection points. So menu, analyze graph, intersection, lower bound, upper bound. There's my first intersection point. And I need to get the second intersection point. So again, menu, analyze graph, intersection point, lower bound, upper bound. Here's my second intersection point. Now I want to do the integral. Notice that the straight line, which is a red graph, is on the top. The blue exponential curve is underneath. So I want to subtract the area under the red graph, subtract the area under the blue graph, give me the area in between the two graphs. You can do that in the graphing page or in a calculator page. In the graphing page, we can do it like this. Menu, analyze graph. I want to find the bounded area, number 7. So as for the lower bound, very carefully move the cursor so it's highlighted. It clearly says point intersection, so I need to use that intersection point for my lower bound. Click. For the upper bound, again, make sure it comes up on the screen, point intersection. You've really got to click onto that intersection point to get the upper bound. So it's exactly between those 2 points. Press enter. Come up down here, 0.652. So that's the area enclosed between the line and the curve to 3 significant figures. If you find it a bit fiddly on the calculator, trying to press the points here, an alternative is to do it in the calculator page. To do that, I need to save these limits so I can get more accuracy. So the lower limit, I'm going to call it A. So hover over the lower limit, right click, remember control menu for right click, store. I'm going to store it and call it A. Do the same with the upper limit, right click, control menu, store, call it B. So now I've got my limit A, my limit B. And I need to remember that it's F2 on the top, F1 is underneath. So now open up a new page, so control, add a page, add a calculator page. I want to do a definite integral to get the area. So on the icon here next to number 9, I want the integral. My lower limit is A. Tab to go up to the upper limit. My upper limit is B. Press tab to go into the main area. Now remember, F2, the line was on top. So I want to get F2. I can either type in F2 or press var. I want F2, x, subtract var F1, x. Maybe I need to put all of that into brackets to make it happy. That'll look okay. F2, too many brackets there. F2x minus F1 x. That looks better. F2x minus F1x dx. That should give me the area. Press enter. So the area enclosed is 0.652 to 3 significant figures, and that agrees with what we found here, 0.652, doing it on the graphing page. Thanks for listening.